Welcome to this section on equations of conic sections. In this section, we're going to look at conic sections as a general rule, identifying parabolas, ellipses, hyperbolas, and shifted conics, and we'll work out some equations for each one. Notice that if we were to take two cones and set them point to point, so they're balancing one on top of the other, you will get these shapes by thinking about slicing through the conic. So here is a picture of a conic, and we have taken a yellow slice out of these conics. So if you slice a conic horizontally, you get an exact circle. So if you're looking at it top down, it'll be a perfect circle. If you slice a conic section at an angle, but not a sharp angle, you'll get something called an ellipse. And that looks something like that. And you can have ellipses that are more oblong, or you can have ellipses that are almost a circle but not quite. Most of you are familiar with what a parabola looks like. If you make your slice through the conic a little bit sharper than an ellipse's slice, you get this parabola shape or parabolic shape. But it's important to note that it does not touch this upper conic section. It only touches the lower one, so keep that in mind. Now, if you were to graph this, most of you know what a parabola looks like. That's what it would look like. And notice that the conic would keep on going, getting bigger downward and bigger upwards as well. And so slicing through creates a parabola, but it keeps on going. Now, for the hyperbola, you're slicing through the conic vertically, and so your hyperbola is now two kind of parabolic shaped curves. One's pointing upwards, the other one is pointing downwards, and they keep on going. So the hyperbola's shape, you have these kind of diagonal lines that represent how you sliced through your conic, and they're almost like asymptotes because your hyperbola curves kind of hug them to positive and negative infinity. And they are symmetric. My graph doesn't necessarily show a perfect symmetric hyperbola, but that's basically the idea. The general equations of conic sections is what we'll look at next, and the graph of the equation can be this really long equation here. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And if you're overwhelmed, don't freak out too much. We'll be refining that equation a little bit here shortly, where we define a and b are not both 0 in a conic. If a or c is 0, it's a parabola. If a and c are equal, it's a circle. If a and c have the same sign, it's an ellipse. And if a and c have opposite signs, it's a hyperbola. We're going to now go into what type each one is and how you can create these equations based on these rules. So in this example, we have the parabola, and remember the parabola has this shape here. It's got It's opening upwards or downwards, and it's kind of got this U shape to it. The parabola is a set of points in the plane equidistant from a fixed point F called the focus, and a fixed line L called the directrix. These two parts of the parabola are going to be very important for you to identify so you can easily graph these moving forward. Here again, off to the right, we have a parabola opening upwards. The parabola has a focus F. Its axis of symmetry is this vertical dotted line. The vertex is its max or min, denoted by V here. And the directrix is this horizontal line just below the max or min. In this case, it's the min. The vertex of the parabola is halfway between the focus and the directrix, and axis of symmetry is a line that runs through the focus perpendicular to the directrix. So if I were to define this, I could say there's a little right angle between the axis of symmetry and the directrix here.